right function keys to press. What did I just do with my glasses?
They're in your car.
Fortunately, I always carry a spare. Okay. Now, let's talk about the 5 orders of ignorance. This is an appendix. This is an appendix out of the book by Philip Armour. The interesting thing is I've owned this book for years. I had never read this appendix until I took over this class from Chuck. And the first time I read it, I thought, oh my gosh, I wish I had read this 20 years ago. Because it explains one of the core essential challenges of software development. And this is a brilliant insight. Software is a knowledge storage mechanism. When we write code, we are encoding information. We are encoding knowledge, not in the sense of data, but in the sense of here are a series of steps that need to be carried out with various inputs and outputs in order to solve a problem. And part of what makes software so hard is, as we're going to talk about, we often don't know what it is we need to know to solve the problem. One of the most important insights that Armour has is that the more they were just sitting right there. The other most important insight is that the more novel a solution we are seeking, the more valuable. I've written a spell check program before, or contributed to one. Oh my gosh, that was almost 37 years ago. If I were to do a spell check program again, I would actually pretty much know exactly what to do. But guess what? I've already done it. There are a zillion spell check programs, mostly embedded word processors now. There's not much value there. If I come up with a new solution, brand new game, something terribly addictive, involving puzzles and presentations no one's ever done before, I don't necessarily know what it's going to take to actually create that, bring it to market. There is a direct correlation towards the amount of invention required in doing software and the value of the software. But the amount of invention required means our programming is going to be less efficient. We're going to have more exploration. We do what he talks about. We determine what works and what does not work for this particular experience. How many of you have had the experience of sitting down to write a program, whether for yourself, as part of a team, part of your work, and you think, oh, this is just a simple matter of programming. I'll do this, this, and this. And you start to get into it, and then you start to discover complications, and you discover that your first solution doesn't work, and you discover that you're down at dead end because it's just not going to perform. How many have had those experiences? Okay? Yeah. That's what we're talking about here. How much code do you throw away in the process of writing code? Lots. Sundog. Early days. This was back. We're talking '82 is when I joined Oasis Systems, and really started on Sundog in '83. It's real-time science fiction adventure. You're a trader with a ship, and you're going from planet to planet, city to city, buying and selling, dodging pirates, trying to earn money, so on and so forth. And I had this really nifty idea. I can't remember what it was, but it's some really nifty idea for some aspect of the game. And I spent probably a good 3 weeks designing this, coding it up, getting the graphics edited, doing everything. And I brought it up on the screen, just this one aspect. And I looked at it and said, yeah, it's not going to work. and pretty much threw it away. A lot of software development is that process. This is the exploration that you have to do to figure out what works, what is useful. A few of you volunteers, what have been your experiences along those lines? How many of you have stories you can tell about going through the same thing? Yeah.
We're trying to integrate with an existing platform, and there was a feature in there that allowed you to use whatever technology you wanted. After exploring with it for about a month, I realized that it was legacy and that they had a new way that was better. So they said that gave you more control and that the long-term solution would ultimately be a lot more effective. So it was painful.
There we go. And it hurts to throw working code away. It really hurts, yes.
I had a molecule visualization app that was in Java, and I guess they came out with Java FX, and so they wanted to throw all the AWS and old graphics libraries in there, and replace them with Java FX's 3D libraries. And so I spent about 2 weeks learning Java FX's libraries and practicing, and then found out they didn't have any 3D. I got paid for 2 weeks.
Oh, there you go, yes. You know, and I have about half of our kids that ended up in IT. And I tell them, the downside is you're going to be learning new stuff all your life. The upside is people will pay you to do it. They will pay you to learn new stuff and stay employable, yes.
Yeah. I worked at a startup company building an app where one of the core features was being able to record a video and then upload it to a server. And with the particular technology that we were using and that we'd already developed a ton of code for, once we got to the point where we could actually record the video, we couldn't get it to reliably upload. And we found out that the particular technology that we were using didn't have a clear way of supporting anything except image upload.
You know, and this is exactly what I was talking about. Yeah, back there.
Yeah, no, so one of my favorites has been when you don't even realize that there's a solution out there that exists. So we were working forever on this, website for this startup, and it turns out we were trying to basically reinvent state management and this other stuff out there. So we spent forever ripping that out and putting Redux in, and then we decided that it was overkill and ripped all the Redux stuff out.
Phil Atkinson was one of the brilliant programmers behind the original Macintosh operating system. Commented on this issue, and he said, I've discovered that a few weeks in the development lab will often save me an afternoon in the library. And one of the issues, one of the real issues, in fact, I just posted an answer and queried this. It said, what common mistakes do junior software engineers make? I said, they don't read. They don't realize what solutions are already out there. They often end up not just reinventing the wheel, but reinventing the flat tire. It's true. All the projects I review, it's true. We'll take one or two more, yeah.
I was just going to say, anytime that I've gone down these sorts of situations and just like pushed forward and revise stuff and whatever, I get to the end of my project and I'm like not satisfied. I just want to rewrite the whole thing. Which feels really bad, but in the time crunch, you never end up doing it. And every time you look back at it, you feel bad about it, but it works, so you just keep going with it.
Two things we'll talk about. Fred Brooks talks about throw it away, because you will anyway. With iterative development, and Brooks comes back and says, okay, with iterative development, you don't really throw it away, you just revise it. But we will talk about technical debt, which is where you push for a solution, and it's wretched, and it's bad code, and you know better ways of doing it. You keep telling yourself, we're going to go back and correct that and rewrite it, and you ship, and the management says, okay, now we want this list of features. You say, no, we have to correct all this stuff. No, just leave it as it is. And you often get this increasingly fragile foundation that your software is built on. Yeah.
Yeah, what you described exactly. I was trying to find a machine learning library to use for iOS. I couldn't find one that met my requirements, so I said, I'll start scratch, so I started doing that. Then I looked a little later, like, oh, there is one that's open source. This.
Yep.
I was gonna say this one wasn't me, but I thought it was pretty applicable because I avoided it. But anyways, I know a guy. So someone that my friend works with got fired because this big project that he ended up doing, he did not read the licenses, and it wasn't as open source as he thought it was, and so it wasn't usable at the end.
Ouch. Yes. Yes. We will also talk about intellectual property in this case. Yes.
I actually have an experience, and I'm curious if this happens often. So, like, at one point I coded something and it worked, and I was super proud of what I'd done. But at the end, like, marketing changed their mind about what they wanted to happen.
Oh, Finn. I know, I recognize her name because she actually interacted with me on Slack. So, yeah, interact with me on Slack and I'll get to know your name. Oh my gosh, engineers and marketing. I have had shouting matches. You promised them what? Our software doesn't do that. There's no way we can make our software do that. But it's the NSA. I don't care. I don't care how many cells you get. It's not going to do it. There's a reason why engineers will refer to marketers as marketing slime. And I say that because I have very good friends in marketing and so on. But that is a classic issue. Okay. Problem of late discovery, which we've talked about. Blind alleys and significant backtracking. One of the readings you'll do for my post is a column I did. A lot of the readings that are my stuff are from a software column I did for what's the name? It's a CIO-oriented magazine online. I did. Do not defer the difficult. It's a natural tendency. If you want progress, what do? Oh, we can prototype. Oh, we can make the user interface. And we've got this, we've got this. You feel like things are going great, and you basically push all the hard problems to the end. So suddenly management thinks you're making great progress, and you've got a half a dozen really hard problems that you have not begun to tackle yet. And sometimes by deferring them, you find that it's becoming increasingly difficult to solve all of them at the same time. There are two kinds of knowledge. One is what does and doesn't work. But sometimes what doesn't work is just as valuable. This is the, don't reinvent the flat tire. No, you think you've got this new nifty solution. Oh, I have a new sort routine. I'm going to bubble things to the top. It's like, okay, that's old hat. We already know what the order of performance of that is. Get a book on sorting and just pick one up. Corrupted knowledge. The code. This gets back to the technical debt. Often we have bad solutions in code that get left there because we're not given the time to fix it. It's considered good enough. Then later someone comes on to maintain it. They look at the code and say, what's going on here? And they think there must be a reason why it's this way. When the reason is you weren't given time to clean up your own mess. Sometimes you just inherit bad code. I mentioned I worked as a contract programmer at Apple. They had bought this multimedia package from a software company that was actually a fairly big name Macintosh software company at the time being 1988. And they were going to use it for some self-running demos and user tutorials. But they wanted some bugs fixed and some new features added. And I started reading it. It was written in Pascal, which at that point was one of my favorite languages. It was the most horrific source code I've ever seen. There was this one routine in particular that was probably about 15 pages long. It was all one subroutine. Probably had 30 go-to statements within it. And this is in Pascal. They had no excuse. This is in Pascal. And I spent about a week or two banging my head against it. And finally, I did a reverse analysis of it, figured out what it did, and threw it away, and rewrote that subroutine from scratch. The resulting one was about 2 pages long, and it did everything correctly. You're going to, how many of you have had to pick up code that you realize at some point is really bad code? Yeah, what's your experience?
Oh, yeah, no, this is what I did all summer. It's my internship, right? right? So this guy had come in contracting to do a web analytics dashboard of some of our data, right? And then he got bored and dissatisfied and left. And no one had any idea how it worked. And so I spent all summer writing. This was his theory, if I can tell him. He said that I have problems with existing UI frameworks that have these flaws. So instead, I'm going to use my own thing that I'm inventing. So instead of trading, the existing flaws that everyone's looking at, now we're trying to guess at what he was thinking. Yeah, so it was loads of fun.
Yep. Yeah.
When I started my current job almost 2 years ago, I inherited a behemoth of Java code that had been through about a half dozen hands over the course of 10 years, and just came out a total mess. And I had to, well, we tried to sort of hack it together to support some new hardware we had, but the plan all along was just to get rid of it. So I spent a year and a half rewriting it in Python, mostly by myself.
By the way, and again, with 40 plus years on my belt, you'll do a lot of digital archaeology. You'll get a lot of code where your job ends up being either trying to figure out the minimum changes you can make to add whatever you need to add without breaking everything, or how to rewrite the whole thing. What the discovery process looks like. Again, you're down here, you can see the peak, and you say, oh, I'll just walk straight through the forest. And of course, you can't see from where you're at the swamp, or ravines, large grizzly bears. And it is an exploratory process. This actually has some interesting implications, by the way, in some of the intellectual property cases I deal with. Where you have situations where there has been substantial analysis and design work done, and one party is making use of that, the other party is saying, wait, that actually represents a fair amount of discovery and work and intellectual property, because if you were starting from scratch, you would have to go through the same painful process as well. This is a graph he's got where he talks about code that you go in a direction, decide this is a dead end, this is the correct solution, and we're going here, that's a dead end, so we're going to go back to here, here's the correct solution, here's the correct solution. That's not working, go back to here, that's correct, go back here. And this, I love this graph because it actually is a pretty good visual summary of what a lot of programming is like. Part of the trick is to remember enough about this. This is his unknowledge acquisition. So that someone coming behind you doesn't say, hey, why didn't we just do this? Because that will happen. They'll say, we have to make a change. They'll be looking at this, saying, oh, we could have just done this. And they'll go off in this direction, and they won't be until they get there and say, oh, now I see why they didn't do that. Because it doesn't work. So he's got his 5 orders of ignorance. You know something, you know that you know it, you can demonstrate you know it. That's 0 order. First order, I don't know something, and I know I don't know it. Second order, I don't know something, and I don't know that I don't know it. There's an important difference here. There's things that you're ignorant about, and you say, well, I really don't know how to do that. I don't know how to make phyllo dough. Okay? I have one bread recipe I can make. And if I wanted to make phyllo dough, I know I could go and look up and find recipes with some practice to it. There are things about baking I don't know at all. I mentioned baking because my wife's currently binge watching Great British Baking Show. It keeps showing me stuff. This is so great. Since I want to bake something now. Third order is I lack a process by which I can discover that I don't know something. Okay, that's cluelessness, pretty much. Fifth order is you don't know about these 4 orders, other 4 orders, but now all of you do, so at least you're at the 4th order, but I suspect most of you are going to be dealing with these 3 orders, and it's useful when you start a software project to ask yourself about these 3 orders. What do you know how to do? What do you know you don't know how to do yet, but you know you can figure it out? And then a place marker that says there are things that I'm going to run into along the way. I don't know what they are, but they're going to crop up. And we're going to have to deal with it. Yes?
It seems to me like the 4th order, the meta-ignorance, is kind of narcissistic and arrogant on the author's part.
You know, you would think so, except that I can recall, I can basically think of work situations where, particularly dealing with management, they have no clue about any of these, and they assume that there's perfect knowledge all the way along. They assume, no, there's nothing we don't know about this. This is our specialty. This is what we're working on. So no, there actually are people like that, yeah.
So what, I guess where would it sit if someone thought they knew something? So they have faulty assumptions.
That's actually sort of the lack of awareness. It's like, you know, well, I know how to do this, and it's only in the process you discover you actually didn't know how to do it. You just didn't know you didn't know how to do it, yes.
I thought I was driving after I read this article, and I was like, the worst kind of drivers are third order ignorant. Like if someone knows how to drive, that's good. If they know that they don't know how to drive, that's okay. But if they think they know how to drive and they don't know that they don't know how to drive, that's the worst.
Yep.
I'm having trouble, when I read this, the second to third jump didn't seem quite so linear. So the second I'm good with, but then when we jump to the third, what do they mean by a process?
Oh, on the third order, like, meaning I don't understand these enough to sort out if I'm solving a problem. I lack a process by which to categorize things into these three categories. So it's a bit meta itself. It doesn't mean it's not something you don't know. It's saying, well, I don't even know how to start and figure out, you know, what I don't know, what I do know, I don't know, and what I actually know.
You haven't started your sorting.
Yeah, or you don't even know how to do it.
So it's like you have second order ignorance, but you don't know how to reduce that.
Yeah.
If you have it but know how to reduce it, then you don't have to.
Okay, so software development. I know how to complete the system. I know what I need to know to complete the system. I don't know yet what I will need to know to complete the system. I don't know how to figure out what I know to complete the system. I have no clue about any of the issues above. Okay? there is a sad amount of software that starts from this point. Oh, of course we can do this. Sure. We can do anti-gravity software. I have to talk to marketing. We cannot do anti-gravity software. It's got a little orders of ignorance cycle. Two important quotes out of the article here. One is that management marketing tends to see software as simply as manufacturing. They do not see it as collecting information. And this is one of the reasons for this big disconnect between management and engineering. Engineering at least intuits and often explicitly knows that really a lot of software development is, frankly, trial and error gathering of knowledge and finding solutions that work. Management and marketing says, oh, you're just putting widgets together. There have been efforts, quite a few efforts over the years to build software by putting widgets together. And you can get to a certain level of abstraction and then you're right back to the same problem. Software components, software factories were a big thing back in the 90s, along with object technology. We'll just build lots of objects and we'll just put them together. Like putting Lego blocks together and it'll all just work. And you discover very quickly that doesn't work because you just put an upper bound on the actual applicability of what you're doing. It becomes too general purpose. Second thing is that the dominant key determinant of software product is the second order, which is knowledge we do not know, we do not know. That's when you start off to do a new software project, that's the rock you are most likely to found upon. Is that you start and you push and you're doing stuff, and somewhere down the road, you begin to discover what you didn't know. You didn't know. It's one thing for me to say, well, you know, I want to write a new database program, and it's going to work this way, and I'm going to have this, and I'm going to have this. And basically, you know, I've got half a dozen books, actually I've got about a dozen books on database design and management. Not that I've read any of them, but I do have about this. I've never had to. But they're there. It's my safety net. But if I were to try and say, oh, I'm going to do a brand new type of database from scratch, and it's going to have this, it's going to perform this, and I dive in merrily, and halfway in the process, I suddenly discover why there are all these books, because there's stuff that I didn't know I didn't know. And it's where I'm going to crash. Nature of the process, we need to identify where there are areas we have ignorance, what questions we would need to ask to resolve that ignorance, and obtain the answers to those questions in a form that we can use. The problem is that we have no way of measuring knowledge and no way of measuring the amount of knowledge in the software, which is one of the reasons why it is so hard to determine how complete the program is. This is the transparency issue. You see a building under construction, you can pick literally just about anyone off the street and point them at the building and say, okay, what do you think? So, well, yeah, you know, they've got the walls up, or, you know, they're building a house across the street. It's a hole in the ground. They're pumping cement in. I assume they're putting the foundation in. And soon I'll see the foundation there, and then I'll see walls get framed, and then I'll see, you know, well, I'll see a frame go up, and then I'll see, you know, walls put in place and roof put in place, and a relatively unknowledgeable person can pretty much give at least a first order estimate as to how far completed the given building is. Try to do that with software. Here is the source code database. Is it done? How close is it to being done? How functional is it? It's an extremely difficult problem, and it is a constantly underestimated problem as to how difficult it is. It is one of the reasons why you have the classic 90-90 rule, which is that the first 90%, the software project takes 90% of the schedule, and the remaining 10% of the software project takes the other 90% of the schedule. I didn't originate that. That's been around for decades, and it's true. It's true. It's so many projects you will get, and you'll say, hey, you know, we're close to being, and you know, for me, a danger sign is when I ask, okay, how far complete? Oh, it's 80% done. Based on what? What do you mean 80% done? Where does that metric come from? And we'll have a whole lecture on metrics. Because there is often this ignorance. We don't know what it is we still have yet to discover in order to finish the project. We have no way of measuring how much of the knowledge necessary for the software to function actually is already there in the software, and how much more we're going to have to put in there. You know, comment, question?
I was just wondering, could you explain that to my wife? She seems to think that I should know when my projects for school are going to be done.
Oh, software's tough, but then one of the professional experiences that gave me the most was Pages, the software startup, doing design-oriented desktop publishing. I did what I thought was a fairly conservative first-order schedule. This was before we hired an actual VP of engineering. I have to go back to just being the chief architect. But we had a target date when we thought we would ship. We were a full year late. And once a month during that year, I had to go, along with the VP of engineering and one or two other people, to our investors and explain why we weren't done yet, what our new estimated completion date was, and why they should believe that, because we've been wrong every time before. Trust me, up to that point, virtually every software project I had worked on had been finished on time through my professional career. We were a full year late. It was the most agonizing experience of my entire professional career. And it's when I started this intense focus on why projects succeed and fail. Because this was a brilliant group of engineers. This is probably the best single group of software engineers I've ever worked with. But we kept running into this problem. Things we didn't know. You wouldn't believe how hard it is to do footnotes correctly in a live document where people are typing into it. Having it reflow in real time. Or just having the letters appear fast enough Humans will not tolerate much delay between when they hit the keyboard and when they see the letter appear on the screen. There were problems that we didn't know. And we were a full year late as a result. I thought it was a great product, great architecture and so on, but it's what set me on this whole path of why do projects succeed or fail. That's the end of that lecture, and that's frankly the end of class today. Are there any questions before we break up as people leave their feet? Okay, once again, get your project proposals out there on the wiki. You know, it's better to have too many than too few. If you've got groups that you already know what you want to do as a group, get it out there, get all your names on here. Next week, we will do that. Also for next week, we'll read, I think, 4 chapters out of Biblical Management.